All right, good afternoon. This is what? June 19th, 2025, and the class is ELEC 1013 Network Cabling, Fanshawe College, London, Ontario. There you go. Here's a preamble speech and a half. Okay, so today we're going to cover something that I call telephone systems, conventional telephone systems. It's the conventional telephone systems is sort of term invented by me because I need to distinguish the VoIP telephone systems and the telephone systems that were implemented just before VoIP kicked in. Right. So this week we get two: the conventional telephone systems and the VoIP systems. Right off the bat, what do we have here on our opening slide? Yeah. Mm, I think we're still recording, right? Yes, we do. All right. We have, well, first thing that you could probably notice that there are telephones or so-called telephone sets. This is a telephone set, that's a telephone set, and so on. Something else that you may recognize by now from our uh, lab session. We do have some BICS frames and BICS connectors that are usually associated with the telephony. Oops. What else do we have here on this picture? We have some equipment associated with the BICS termination. BICS stands for BIX, Building Industry Cross Connect. That's the acronym for BICS. So we have a BICS punch tool, BICS frames, connectors, and some patch cords that could be associated with this modular telephone system. So right in the middle here, we have a small box well, it's a discontinued telephone system. However, because the Norton Telecom telephone systems were so good, they are still quite popular these days, even though Norton Telecom is, from the best of my knowledge, is out of business right now. There could be some kindling left that just to keep the flame going, but I'm not sure. However, the official thing was that Norton Telecom line was discontinued. However, those phones and the phone systems are so amazing that still a lot of them are being in use. In fact, that you can still buy some refurbished equipment, and some of it I could be fooled that it's made new. Maybe someone offshore is producing it or not. I just don't want to start any rumors, but I could be fooled. Okay. Well, aside from the Norton Telecom or so-called Meridian telephone systems, there were other things on the market, other brands. Like, for example, Panasonic. It's still a nice, good going brand, standing strong with the telephone systems. Toshiba was there, still is, and some other brands that are more or less known to the market, okay, to the general public. What do we have here? Here we have something that was labeled as 3 by 8. 3 by 8 means that this little box that is called KSU or PBX, more likely KSU, stands for Key Service Unit, which is a box that acts as a traffic controller, um, sophisticated traffic controller or glorified traffic controller for the telephone traffic that goes in and out and through certain company, office, business, an enclosed entity that can be labeled as, like, let's say, business. Uh, 3 by 8, 616, and modular, for example. 3 by 8 means that this KSU was able to, or is able to, take 3 incoming telephone lines, POTS lines, and he was able to branch out on the other side into 8 telephone sets. So 3 by 8. Popular solution for a small business, really small business. 8 telephone sets, 3 incoming lines. That was it. Then there's a little bit bigger box that is called 616, which, as you could probably guess by now, is able to accommodate 6 incoming lines and branch out into 16 telephone extensions, 16 telephone sets, proprietary telephone sets, as opposed to single line telephone sets. What's a proprietary phone set? A proprietary phone set or telephone set is a telephone set or telephone that is made for a specific telephone system. So if this was Meridian telephone system, you would need Meridian telephones to be able to connect, to be able to understand the signal that goes between the telephone box or KSU and the telephone set. You would not be able, excuse me, you would not be able to connect a single line set, which is just basically POTS type of telephone set, the one that you can just buy in a hardware store or online or whatnot, and you can connect to a POTS line. This telephone set, you connect it to a POTS line, which is the incoming telephone line from outside. It will not work. It just works with this particular telephone box. So by the same logic, things like Panasonic phone systems, they will have their own proprietary telephone sets. Toshiba, other ones. So this here box 6 by 16 or 616 is able to take 3 CO lines and branch out into 16, sorry, 3 by 8, 6 by, oh man, 616, 3 by 8. Telephone lines in and the proprietary telephone sets. Now we have also modular KSU, or more towards PBX, and I'll tell you what the differences are, sort of. Okay. This one here, you could just build. You need more telephone lines, you add another module, interface that with the existing system, and you have more telephone lines if you need. You need more extensions, get another module, pop in another telephone extension card, and you have more telephone extensions, and so on. So that'll be expendable one way and the other way, both ways, like, so towards the lines and towards the telephone sets. So this would be more modular type of a system, as opposed to set in stone. This one here, 3 by 8, that's it. You can get 3 and 8 telephones. 616, same, that's it. It's not expendable. This one is modular phone. Now, some of the smaller telephone systems, they would have telephone jacks here that you would just plug in with the telephone cord into that. So 3 of those or 6 of those. Now, the bigger ones, they would have the Amphenol connector or the 25 pair cable connector, RG21. And over there, you plug in the 25 pair cable and you bring it out into the BICS block, and then you terminate just like we did during our lab, 25 pair cable. And there would be, let me just see here. There will be a manual. In the manual, there would be a pinout of, let's say, for example, this is a 616 system. So the phone lines would be, for the 616 phone lines, they will be plugged in by the jacks, and the Amphenol connector branched out by the 25 pair cable terminating on the BICs, and this would be the pinout explaining of which pair serves as what. So for example, see here's 25 pairs. Okay? And you remember the colors. Here are the group: white, red, black, yellow, violet, and there's the blue, orange, green, brown, slate, blue, orange, green, okay, and so on. So here's pair one that would go to extension number 1, 2, 3, and up to 16 extensions. So this will be the 616 wire. Now notice that the first extension doesn't start at 0, doesn't start at 1 or something like that. Like for example, this one here says 21. So some of the, depending on the software that is installed in the telephone system, in the box, you could have 2-digit extensions, 3-digit extensions, or sometimes 4-digit extensions. So the first one would be 21, or the 3-digit extension would be 221, right, and so on. Or the 4 digits can be 2221, right? So if you want to dial somebody, maybe in the reception, usually that would be the reception phone. Doesn't have to be that. Usually it will be. If you want to call a reception, pick up the phone, say dial 21, and the reception phone would ring. If you wanted to make an internal call. Then what else can we see here? Pair 17, 18, 19, 20, and 21, they're just unused. Now here, at the last pair, we could see here, and I guess I kind of made, no, kind of, I put a bold font on the first letters of the word, because MOH is an acronym that it's used for music on hold. There is, I'm going to tell you just before we leave today, something more about that. Music on hold. So that would be an input to the telephone system. What would you connect? In the past, or we would connect would be just a standalone radio that would be purchased anywhere in some kind of a hardware store or department store. It just had to have the headphone output. So we would just plug in the headphone 1/8 or 8-inch, which is smaller than just a headphone jack, into the plug or into the headphone outlet. And from there, we would just branch out and punch into the last pair, and that will be music on hold. So if somebody's being put on hold, they will listen to somebody having some fun with Casio keyboard and calling it music, or something like that, or maybe a radio station. Okay. Now here, as opposed to that, like this is an input. This here, pair 22, would be an output. It says external paging audio. So from that, you would get a pair, punch into that pair with a cross connect wire, and you would connect that pair into an input of another amplifier, on an amplifier that would be connected to the paging system and connected just as we connected in, I think it was lab number 2, which was the PA system. So it's all coming together, the stuff I'm showing here, right? There is another thing that says external paging contact closure. Well, these two go together usually, and that's let me explain how the paging amplifiers work. That was from the previous class. All right. So here is a paging amplifier, PA amplifier. Okay. And of course, here is the bus, audio bus, to which we have the speaker station connected. Speaker stations, all right, and speaker stations and whatnot, just as we connected that in our lab. So that's an output. Okay. Now here's an input. How can we do this? Let's say here's an input from the phone system. at the back of the amplifier. And at the front, you would have maybe some volume controls and things like that. So this is from KSU. Remember, KSU stands for Key Service Unit, which is a processing unit phone system. So if somebody wants to do an all-call page when there's some phones connected to the KSU and distributed all over the place, here's a phone, and whatnot, all right? And somebody decides to do a page, an audio page, and they want to do, let's say, all-call announcement. They pick up the phone, and either they press the button on the phone that is programmed to activate the audio page, or they have to dial the feature. So there's going to be feature number and maybe a 3-digit number that corresponds to the feature that enables the paging. Either way. What happens that the audio output, this one right here, that is activated. And it's connected to the phone that the person is using. Because you can do a page from any phone, provided that the phone is programmed as to have the permissions to page. So you get direct connection from the microphone of the headset through the KSU to the input of the amplifier, and you do the page. Then you hang up, and the page is done. So-and-so, please come to the office, or whatever. All right? Here's the problem, is that this input is always active. So if it's not being used by doing a page, it is going to pick up noise, interference, and you're going to hear some annoying buzz all through the speakers all day long. That would not be a very convenient situation. So what was established as a solution for that was another kind of like an input enable connector. So let's say here's an input enable connector, another input here, and that could be just, if you magnify it, that just could be a couple of terminals. And if you want to activate the input, you would just join it with a wire through, just with a piece of wire. And then that input would be enabled. Otherwise, if it's open, if it's not joined, then the input is deactivated and there's a silence in the speakers here. And so this here goes to the KSU and it would be connected to this here contact closure. This would be just a relay. And if we don't know what relay is, a relay is a switch. And here's the terminal of the switch. And that switch is activated by an electromagnet. And it's basically enclosed in some sort of chassis. Oops. Let me just do it sort of anatomically properly so the terminals are exposed. Okay. So here will be the coil terminals of the relay, and here would be the dry contact, because physically these two are independent. They are not touching. The electromagnet closes the switch closes. So if you activate that, so just giving a voltage, or sometimes just a closure here. So over here, these two terminals, this one and that one, would be these two, the pair 22. Right here, sorry, 23. So it's just like closing those two terminals. So these two work together. If you activate the paging, the audio paging, then that follows and it closes activates the input, and the input is able to receive the audio. You speak to the microphone, you do the page, you hang up. That input is deactivated from the KSU, and the relay is open, so the input is deactivated. So that's the that's the idea for the external paging contact closures. Not all the amplifiers have that, but the commercial paging amplifiers, they will have those contacts. And if you are purchasing any of those paging amplifiers for that purpose, well, it's a good idea to make sure, just to confirm that that the amplifier does have that input enable terminal or connector or feature. It's just pair 24. It says auxiliary ringer contacts. Now, that is also a relay. Same thing, but it acts not the same as this one. Oh, it's the same but different. Because this here, the external paging closure, is tied to work together with the audio output of the phone system. This one here is a relay, but it's activated on a little bit different basis. Let's say, okay, let's just get another. We're looking at auxiliary contacts. All right, so let's say we have a big production hall somewhere, huge production hall, with a whole bunch of machinery making noise and whatnot, and blah 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 blah. Right? Something. People are working there doing a bunch of noise, and over here somewhere there would be maybe a supervisor's office here with the desk, and the phone on the desk, and door to get in. Well, usually the supervisor would be in their office. However, sometimes the supervisor's job is to walk with the people on the floor and help them because there's some issues and whatnot. So sometimes the supervisor will be out of their office, but the supervisor needs to be contacted, be able, the office needs to be able to reach them. And if the supervisor is out there with all the noise, there's no way they're going to hear the phone ringing in their at their desk. So what can be done is just a small example of an auxiliary ringer can be installed right here. I'm just going to indicate that this is making noise and flashes the strobe light. So that auxiliary ringer can be programmed to follow the ring on that specific telephone. So in the programming of the telephone system, you can, like, for example, this 616 phone system only has one of those. There are some other bigger telephone systems that have more than one of those auxiliary ringer contacts. So if that auxiliary ringer contact, this here pair, is programmed to follow any of those, let's say the supervisor's extension is 31, so tied that in programming to 31. So if 31 rings, that auxiliary ringer contact is going to activate and it's just going to close. And the auxiliary ringer would have, let's say, if it's magnified. So here is the auxiliary ringer, magnification of that. And it would have maybe some strobe light here, okay? And maybe it's going to have some sort of speaker or the piezo speaker to make noise. And it is going to be plugged in somewhere to a transformer somewhere there. Yeah? And it's going to have those contact closures. So if you just take a screwdriver and just make sure these two touch, then that thing is going to go nuts. It's going to make a heck of a lot of noise, and it's going to maybe, some of them are just noisemakers, some of them are just strobe lights, some of them have both noisemaker and a strobe light. So when you close those or these auxiliary ringer contacts, then this device is going to activate, make a lot of noise, flashing the strobe light. That means somebody is trying to contact the supervisor, so they can go and pick up the phone. Now with today, these days, everybody's got the cell phone hanging off their belt and whatnot. But before, people didn't do that. However, the employer cannot rely on somebody having their phone because they're employing that person. So usually things like that would be installed like that permanently. Okay? And this auxiliary contact also, it can be, aside from being able to tie this to a certain extension or telephone set, it can also be programmed so it's active during certain times of the day. There we go. Where were we? We were here. Now, next slide is the list of the telephone features that I'm going to go over later, because if I just go one by one, for sure I'm going to put you to sleep. Okay, so I'm just going to touch on some of these here. And right after we come back from the reading week, we're going to take a little bit of more detailed look at this list here. BICS connections are associated with phone systems, and we're talking about the conventional phone systems as opposed to VoIP, about which we're going to talk tomorrow. It's a typical cross-connect field, and this one is done by BICS, and BICS is by far the most popular cross-connect field for telephony. Just by looking at the picture, what can we say? This looks like a secondary demarcation point. This is just a ground bar. A lot of equipment has to be grounded, and the ground bar is provided. So looks like a secondary demarcation point. What would be a secondary demarcation point? Another page. Again, let's say here is a building, huge building. Let's say it's a big shopping mall. Somewhere in the basement of that shopping mall, there would be a room, big room, that is having all the connections from outside, telecommunications, fiber optics, telephone lines, coaxial cables, whatnot. This would be the main demarc point. The okay. Demarcation point is a point of entry. So that's all where all the cables are coming in. Now, because it's a huge shopping mall with hundreds of shops, then things can be divided a little bit. Maybe another floor or somewhere, or maybe somewhere on the same floor, there will be another, maybe somewhere halfway there, maybe another communications room that may be servicing with telephone lines and communications branching out for that side here, part of the mall. So you would get some of the lines, of course, running under the floor or in the ceiling, being extended to that. And maybe there's going to be another demarcation point that some of the lines are going to be extended to here and so on. So this would be the main demarcation point. And over here would be secondary demarcation points spread out through the building if it's a huge building. So what can we see here? These look like there are lines, 25 pair cables. See how many of them? There are a lot here, right? These are all 25 pair cables. They are being brought into this cross connect field here, into those frames. So there's 1, 2, 3, 4, 10, 20. Looks like there's 20 cables here. So it looks like it's a huge facility. There's the lines coming in, and then maybe there is another big field that carries on, like those wires could be going to another demarcation point. And over here is something that's called a cross connect wire that's being used to cross connect between one pair and wherever it has to go. So remember when we did the termination of the 25 pair cable, we terminated it at the front and we had to flip it so the terminated wires 25 are at the back, so we could grab the pairs from the front in order to do the cross connect punch. And we're using cross connect wire to connect between those. So it might look like a little bit intimidating at first, but when you're looking at this and I'm explaining that to you, it's becoming less and less muddy. Here, of course, is the 25 pair cable terminated on the BIGS frame, just as we did during our lab. And this is one of the students' work from previous years. Now, so here's the BIGS frame, BIGS connector, 25 pair cable terminated on that. And over here is the RJ21, and the X stands for either male or female, because sometimes if you want to extend the 25 pair cable, you can just terminate both male and female on each end and just plug that into each other, and then you have a cable extended. One way of extending telephone cables or intercom cables, the 25 pair. The other one is using isolation displacement connectors, like, for example, the B type of a connector. Please don't let me forget. I gotta show you what the B connector looks like, and maybe I can show you how to use that in order to terminate that. There's this famous something that's called the B cap flower, because the B connectors are called B caps, and in your case sometimes they call them beans. So whatever. So I might show you some ways of termination, or you can use the RJ21 connectors. Of course, the RJ21 connectors, this is also the one that plugs into the phone system, so things can be branched out so they are manageable as far as cross-connecting that. And that's what the RJ21 connector looks like. It plugs in right here. Or it plugs in here inside if you open the flap, it plugs in here. So these smaller ones, the CO lines, central office lines, are coming in and just being plugged by the jacks, and the M-Funnel connectors are being brought out here. Oops. Okay. Now, in order to terminate that, there's two ways you can get those. You can get those pre-made, and you got to specify the length, 6 footers, 20 footers, 25 footers, with that connector already being put on, and then you can just terminate the BIGS. But sometimes you might want to terminate those yourself, and here is a thing that is called a butterfly tool. It used to be expensive. In like 90s, you would have to spend $600 on one of those. Now you can probably pick one up for $50 on eBay. Similar way of terminating. You just bring those wires here, doing according to, let's see, these are the group wires. Here's white, red. There's going to be black and yellow and violet here. And here will be destination colors from those pairs. And then after all those are pre-seated here, then you close the flap here, close the flap, close those arms, and those, of course, you have to put in a connector. Watch the short, really short video on how things are done when it comes to doing the butterfly tool to terminate the 25 pair cables onto the RG21 Amphenol connectors. And here is how things are being done here. All right. So here you see there's 3x8 small telephone system. The lines are being brought in by the jacks and funnel connector to break things out according to the pinout that is going to be provided. And that's how we are connecting things. Tip and ring, we have already talked about that. So this is just a refresher on how things were done, because this is supposed to be serving as standalone presentation. So the central office would look like this, and the telephone connections would be patched manually by humans. Later on, the central office would look much more computerized without people at all. And here's the 1/4-inch connector. Here's the tip. Here's the ring. And sometimes you get the ones that could accommodate the balance signals. Will be tip, ring, and sleeve. Sometimes they're being used for balance audio signals these days, and the guitar players, they would recognize this kind of plug right now. All right. Again, recap on the tip and ring. Remember that a lot of people got this wrong on the test, more than I wanted to. Tip is more positive. See, tip is more positive than the ring. Tip, positive, not as positive. This is more positive than that. Tip, more positive than the ring. However, the tip is tied to ground. So the ring is being more negative than the ground, actually. Here's what auxiliary ringer looks like. It's mounted on the side of the outside of the supervisor's office, for example, just an example. What do we have here? So we have something that's called ATA. ATA stands for Analog Telephone Adapter. What ATA's job is to translate any of the signal that is proprietary to that phone system into pots. So see, in fact, if any of us have something that's called telephone over internet, so it'd be just a regular telephone, but it's not connected to the POTS line, it's connected to the internet, and the internet provider company, if you purchase that type of phone service from them, they would give you so-called the telephone box or the phone box, which is nothing else than the ATA, analog telephone adapter. It translates the one of the inputs here plugged into the Ethernet, to the switch, or to the modem. You can choose which one you want to plug into, depending on the setup. And here are 2 pots, jacks. You can plug in a telephone here. And if somebody dials your number, that thing here, that pots thing, is going to give you a ring signal to the phone. And you can pick up the phone and talk, or you can pick up the phone and dial the number. This box is going to generate a dial tone. It's just going to look like a regular telephone. So that's ATA. In fact, look, if you zoom in, it says ATA. So if you have any of those, just take a look. Now, why would you want to use ATAs? Well, multiple uses. You can connect a regular phone to it. Like, for example, you have a company that it's an office building, and the office building is closed to public, but sometimes you might want to let some people in. So in the lobby, there will be just a regular cheap $9 telephone. If somebody destroys that, nobody's going to cry, they're just going to replace it. Because those proprietary telephones are, $300-400 each. So that could be in the lobby, the regular phone, but the regular phone, POTS phone, doesn't understand the telephone system signal, so it has to go through an ATA adapter. Somewhere in the communications room, one of the jacks is going to be, this would look like a different ATA adapter, because every telephone system has their own ATA adapters. The common denominator of that is that the output of that is always POTS. Whatever the input is, it's whatever that fits that phone. This looks like a VoIP telephone system, or telephone box that you would get from your internet provider for your home. So in the lobby, there could be just a single line telephone set, and single line telephone set is the SL single line set POTS telephone that you could buy in department store. And that's could be wall mounted in the lobby that is close to public, so you can call the reception from there. There could be a little bit of a list or something, and they can let you in. Other things, the ATA adapters can be connected to something that's called the door stations, which would be a station, what I keep calling it, on a stick by the truck driver's entrance. If somebody pulls in with the truck, that push button station could be extended height wise, so the truck driver doesn't have to come out of the truck. They just push the button and it hot dials. What's a hot dial? A hot dial is if you pick up the handset or push the button, it dials a specific thing. It could be an internal extension, or it could be an outside line and a specific number. It hot dials a bunch of department stores. Sometimes you're going to see telephone on the wall by the entrance or the exit of the big department store with just a handset and no dial pad. It's a hot dial phone, and usually that's installed by the taxi companies. So you can have 2 or 3 of those beside each other, everyone from different purchased and installed by different taxi company. So you pick up the phone and the thing dials by itself. The only one number that dials, because there's no way for you to dial anything. It doesn't have a dial pad. It's a hot dial thing. So if it's a truck driver's entrance, there would be a telephone without a handset, but with a push button and a speaker. So it will act as a speakerphone. And you just push the button and it hot dials, but it has to be connected through ATA adapter, because those are made by third companies and they all work on POTS system. So it has to be connected to a POTS line. But the telephone system doesn't have originally the POTS line. It has to be connected through ATA, analog telephone adapter. Another use for the ATAs would be using paging interfaces. Paging interface also is, now I know that sometimes you have to go to another class. If you have to go because it's 10:02. I'm just going to spend a couple more minutes explaining, and you can catch the rest of it when you at the convenience of your at your convenience. Okay. So let's see what new here. What was I explaining? I was explaining paging interface. Okay, that's a common, and you can look at the paging interface by Bogan. Bogan is pretty much probably the most popular company that does telephone peripherals like paging interface. Let's say here is a actually, you know what? Oops. Here, I don't have to draw. See, here's a paging interface. Here's the phone system Here are the extensions by the Infinite connector plugged in here. And ATA is going to be plugged in as a telephone extension. The ATA is going to make the phone system think that it has one of these phones plugged in. It has the same circuitry as the telephone set, except it doesn't have a display, it doesn't have a dial pad, it doesn't have a handset, but it has the guts of the phone. But what it does is that it has the pods output, to which there's another ATA. A regular telephone can be plugged in, or a door station with the push button can be plugged in, or a PA system paging interface can be plugged in. Because paging system, PA interface, it looks for the pods type of a signal. So here's the pods output, here's the pods input, just a regular telephone cord, plug it in. Now, the paging interface, once it senses the ringing signal, because you can dial the extension number of the ATA, because the ATA boxes, once plugged in or programmed otherwise, they will have a telephone extension number, just like these do. So you dial the extension of the ATA adapter, it is going to make that pods jack send a ring signal, which the paging interface is going to sense. It is going to respond automatically, and it can go two ways. It can give you a confirmation tone, after which you may just speak, and the audio is going to be distributed over the speakers. Or the confirmation tone could mean that you need to specify the zone that you want to page. And the zone could be 1 for the offices, 2 for the production plant, 3 for all call or something, whatever the programming would be. So that paging interface can be programmed to work one way or the other, because the paging interface can serve as a multi-zone paging interface. The reason for that is, let's say, for example, you have a huge production plant and you have the offices, you have the shipping and receiving, you have the production plant, and so on. Let's say there's a lot of pages going on for the shipping and receiving, because during the day there could be some traffic going on. Here's a truck came to unload, here's whatever. So that shipping and receiving department could get a lot of audio pages. So the offices, people in the office, they don't need to hear all that. So that those speakers can be put on a separate bus audio line. And there's two ways of doing this. It could be connected to a specific amplifier channel, and the paging interface could activate that audio channel and send it to that particular amplifier channel that is connected to this array of speakers. Or you could have one amplifier and the speakers would be connected not to the amplifier, but to the paging interface terminals, and the output of the amplifier is also connected back to the paging interface, and the paging interface is going to decide which line of speakers to activate in order to do an all call, zone 1, zone 2, or zone 3, or whatever. So ATA adapters are being used for that. That's where we were. Now, here I just wrote what I wrote. I will let you read that later. But I'm going to tell you a specific example of what happened, because it says, well designed. Okay, I'm reading it now. While designing a system which involves interfacing ATA adapter to other peripherals, such as paging interface or loud ringer, confirm the specifications of all devices involved. Different devices might be by different brands, bearing different input-output levels, even from the same brands. Best thing, read the specs and confirm in practice. This can save you a lot of time and aggravation, especially while designing a larger system involving purchasing and installing multiple devices. Mouthful, right? I had a situation when I was retrofitting one of the big production plants with the VoIP phone system. So I had to disconnect their conventional system, and instead I had to activate their new VoIP telephone system. But we were to keep that existing PA system with the speakers all over the place. So the PA system to be disconnected from the old telephone system and interface with the new telephone system. How did we do that? We did it through ATA adapter. So the other ATA adapter was disconnected from that, and the new ATA adapter for the new phone system was connected to that, and everything should be, with a little bit of programming, everything should work as it was as far as paging. So the problem was that everything was connected, and we just do the test page, and this PA interface does not want to react to that ringing. Spent countless hours, no, a lot of time actually, excuse me, making sure that the connection goes. Did I do the wrong connection? Did I construct the wire in the wrong way? What did I do? Is it plugged into the proper port? Yes, yes, yes. Still doesn't react. Maybe there's a break in the wires. Made up another wire. Nothing works, nothing works. Contacted the company for the phone system just to confirm things. So, yeah, everything is good. Contact the company that was producing the manufacturer of this here, just making sure maybe there's some dip switches that maybe we have. No, everything is fine. It still doesn't work. The problem was that when the company who sold the phone system, they had their own Mac setup on their floor, wherever it was, and things were connected actually physically, and it worked. And they sent us the same equipment with the same specifications, same brands, and da 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 da. And over there it works, and over here it doesn't work. And I can't turn out that since the time that the company who sold the phone system, they did their own mock-up system in there just to have it, to make sure that everything works. And then by the time that the system was, the contract went through and the equipment was delivered, installed, few months has gone by. And the company, whatever it was, they changed the revision numbers. It was the same model number of the ATA, but they changed the revision number, and it had slightly different specifications. It was not producing enough, either current or voltage, we don't remember now, to activate the PA interface, and it was just not getting enough juice from that. Same model number, just a different revision. So that's why I did that. Sometimes if you end up working in this field, just like everywhere else, sometimes you're going to have a nice and smooth working day and everything is fine. You're driving home with a smile. And sometimes you're going to have situations like that. This would be one of them. Just want you to remember to, I just want you to remember what I just showed you. Okay. USOC, that is another recap from other classes, other lessons that we had. With the telephony, USOC is the convention for the wiring. You see, we go with USOC, we go pair number one is the middle prong, and we just go outwards with the pairs. This is the old color code, this is the new color code, and that's how they correspond to each other. USOC applies only conventional telephony. USOC is not used in data connections. We use the T568 convention that we already have done also. The jacks might look the same, the cables might be the same, but the color code configurations are different for data and for telephony. For data, it's T568A or T568B, well, T568. Okay. The Universal Service Order Code is a specification system developed by Bell System in order to connect equipment used in customer premises such as homes, offices, You can read that. We just went over that in the previous classes. If you have any more questions, please go ahead and ask. And USOC stands for Universal Service Ordering Code. It's a standard, it's a convention for wiring the jacks for telephony. Examples of jacks. Here's a typical surface mount jack. Here's a typical wall mounted jack. And here's a typical modular jack. Surface mount, you can see this one here. It's capable of 2 telephone lines. But nowadays, usually we would just use the pair 1, which is red and green, tip and ring, which is connected, you see here, it is connected to the 2 middle prongs. And that's all we're connecting. The other ones we use unused. Those jacks were used heavily, this type of connection, if there will be a telephone with multiple lines capability, but those are not being used anymore. So if you have all those, you just connect these two. Same thing with the wall mount. Here's the terminals, red, green, black, and yellow, but you only connect the red and green here because that goes to tip and ring. Now, modular jack, the modular jacks, those data jacks that we worked with in the last couple of weeks, they are able to accept the telephone plugs, which would be from the telephone cord. So remember, if we wire that jack just for the phone, all you need to do is to terminate the blue pair of the jack, not of the cable. The telephone line could come in on the blue pair, so you connect it to the blue pair of the jack. The telephone line could come in on the orange pair, and if you wanted to have that working as a telephone, that orange pair still has to be terminated on the blue pair of this jack, because the blue pair of this jack is connected to the 2 middle prongs, just like the red and green is connected to 2 middle prongs. Okay, a lot of people got that one wrong as well. We're going to reinforce that knowledge by having one more lab. Here is the registered jacks types. Here's RJ11 or RJ12. They look the same, although I think they look, when I size them the same. The RJ12 has 1, 2, 3, 4, 5, 6 prongs, and RJ11 is the same size. It just uses 2 pairs, 2 middle prongs and 2 outside prongs. So that's pair 1 and pair 2. And the other 2 slots are empty, so that's what makes it RJ11, registered jack number 11. And here, registered jack number 12, typical telephone cord. RJ22, smaller jack, it's the handset cord. And of course, here's the good new RJ45 that we can wire up either in USOC configuration, but most of the time we're going to keep wiring this thing in the T568 type of convention for data. All the RJ plugins which typically handset cord will physically fit in. Okay, so if you have the RJ45 jack, not plug, because this is a plug, the jack is able to accept those RJ12 or RJ11, same shape. And it will connect those 2 middle prongs to the 2 middle prongs of the jack, just so you know. So you can use data links if it's a dry link from one end to the other. If you plug in the phone cord on one end, you can plug in the phone telephone on the other end and use that link as a telephone connection. We already went through this. And here is is that the last slide? Yes, it is the last slide. Just a typical conventional type of a telephone system. Here would be a KSU or PBX. Now, when it comes to KSU or PBX, PBX stands for Private Branch Exchange. And KSU stands for Key Service Unit. They are the same. It's the same thing, KSU and PBX. However, if it's a bigger exchange, like for example, small business would have one of these or one of the, not the voicemail, um, like let's say one of those. So it's capable of 6 telephone lines and 16 extensions. Typically, you would hear that being called KSU, Key Service Unit. But if somebody says that PBX, like the world is not going to stop spinning. All right. Uh, Now, if it comes to bigger phone systems, internal phone systems, like for example, a hospital, a huge hospital that would have maybe 900 phones altogether, then you're not going to get a box like that. You're going to get a whole room with a bunch of furniture and connectors and whatnot. And that the technicians would have tendencies to call that PBX as private branch exchange, as opposed to like local exchange outside the building, like the city central office local exchange that services maybe a couple of neighborhoods. And this would be PBX, private branch exchange to service the phone traffic within the specific building or facility. Okay? Now, over here we have the RJ21 MPNL connectors through the 25 pair cable brought to the big terminations, terminated, flipped at the back, and pairs can be grabbed to be connected to other field wiring BIGS connectors, cross-connected one by one to go to either of those telephone sets. A voicemail can be interfaced with that. And over here we have an ATA adapter that is connected. It's using one of the extensions spots. And over here we can connect a lobby telephone if we want, because it has a single line POTS jack on that. Or we can connect door station. And I don't want to spend too much time on that because I know I did the second part with the other group and I'm explaining that in detail. So I don't want to explain it twice when I was doing the beginning of the VoIP systems explanation, okay? Auxiliary ringer can be connected right into those right here. So the ringer contacts for this particular system. A different one could have different pinout, okay? And of course, the point of having a phone system is to have telephones. So there's a bunch of telephones connected to these pairs right here, one by one. And then over here we have the paging interface, and I explained that maybe 7 minutes ago on how to do how that works. One more thing that is here is a single line telephone, and I labeled this thing as a 911 phone. Notice that the line that is supplying the basically regular single line telephone set, POTS type of telephone set that hangs on the wall somewhere on in the production hall. It is not connected to any of the equipment. It just bypasses everything. It takes a straight route as possible to the line that's coming straight from outside, because that is independently powered. This functionality of that phone does not depend on the power to the building. That's a 911 phone. Sometimes it's required to be installed. So if something happens, somebody is able to dial 911. One thing I'm going to leave you with, same as the other class, that I mentioned that music on hold. It used to be that you take a radio, headphone jack, plug into that last pair or whatever it is on a different system, maybe has a different input somewhere. And if somebody is being put on hold, then they will listen to the radio or MP3 player or whatnot. Now, somebody had a great idea, and I know it's a great idea if I get quote unquote jealous that why didn't I think of that? It's awesome idea. They created something that's called music on hold industry. Instead of having a radio connected to a telephone system, so if somebody gets put on hold, they listen to some music, why not give the client a box that acts almost like a miniature PC with the hard drive or maybe some memory modules there that is connected to the internet, to the modem, so I can log into that box from outside, from wherever I'm in the world, and I can connect to that box and upload content. And the output of that box is going to be connected to the MOH, music on hold input of the telephone. So maybe once a month, maybe once every 2 weeks, I'm going to meet with that man. I'm using that term loosely when I say I, okay? Here's the idea. So I'm going to meet with the management and say, what do you need to be advertised during this month? And they say, okay, we need to advertise this tires, this cleaning products, this whatever. So just, we'll have special on this, that, and the other thing. So just make a audio loop that advertises those services, those products, and all that stuff, and make maybe a 3-minute audio loop that just loops and just keeps playing all over again and again and again. So if somebody gets put on hold, they get to listen to the company advertising instead of some music. And of course, when I do that service, I'm going to charge the company that I provide the service for, maybe monthly or per service, whatnot. But here is a business idea. So music on hold, sometimes if somebody says that to you, that here's a service call that we have to install the MOH box. That's what it is. Get that box being shipped to you. Mounted on the wall somewhere on the plywood backing there, connect one end to the internet or the to the Ethernet port, to the switch. The other one, audio output, connects to the phone, and maybe make some phone calls to confirm that this thing is working and all that stuff. So music on hold can be, you can plug in a radio, and sometimes the MOH devices are being distributed because somebody had the clever idea of establishing that type of a business. Okay. All right. So this is as far as we can go with me showing you the basic idea of operations of the telephone system that is a conventional telephone system, and the conventional telephone system uses CO lines, POTS lines to connect to the phone system here, as opposed to VoIP system that works completely in a different way. We don't have the physical CO lines anymore. We're going to use the chunk of the internet that is provided to the building in order to use the telephone communications. But that's a topic for tomorrow. In the meantime, ladies and gentlemen, that's it for today. Have a great rest of the afternoon. Thank you. All right, so